next kind of triangle I want to consider is a 30, 60, 90 degree right triangle. So let me just draw one, a real crude sketch. So the right angles here. So this angle here is 30 degrees. This angle here is 60 degrees. So let's assume for a second we have two legs. We have this leg, which is the short leg. So let me call this A. The short leg is the one that's across from the smaller angle. And this one has to be the long leg right here. Use the mouse. Right there has to be the long leg. And the hypotenuse is obviously right here. Okay, so let's assume that we're given the short leg. Okay, given the short leg, how do we figure out the other two? Well, it isn't, if you look at it a certain way, just imagine that there's an imaginary line right here. And I'm going to take this triangle and flip it over, and I'm going to make like a ghost triangle down there. It's exactly the same thing. So this is 60 degrees and this is 30 degrees. Now, if you notice, what I have is, if I look at now the triangle as a whole, so now if I look at this full triangle right here that I made, this is 60, this is 60, and that's 60, which means if this is A and this is just a reflection, that has to be A, which means the length of one full side is 2A, and since it's 60, 60, 60 triangle, it's equilateral, this also has to be 2A. So right away we have that knowing the short side in this triangle, the hypotenuse is double whatever the short side is. So now all I have to figure out is how long is that side right there. So let's call that x, since we don't know it. And we're going to use the Pythagorean theorem again. So here we go. We have a squared plus x squared is equal to 2a, the whole thing, squared. A squared plus x squared is equal to 4a squared. The 2 gets squared, the a gets squared. So I can now subtract a squared off of both sides of the equation, and I end up getting that x squared is equal to 3, that's a subtraction, 3a squared. So here I am pretty much done. Now this side then, if I take the square root of both sides, okay, I end up getting x is equal to, now the square root of a squared is just a, and the 3 isn't a perfect square, so it has no choice but to stay inside. So that's our answer. The longer side, the side that's across from the 60-degree angle, that side there has to be related to the short side, is whatever the short side is multiplied by the square root of 3. So let's cook up a few examples. Given this right triangle, okay, here's 30, here's 60, here's 90. If I tell you that this is 7, then the hypotenuse is 14. It's double. The long leg of this right triangle is going to be the short leg times the square root of 3. You can actually put into the calculator 7 times the square root of 3, and it'll give you a numerical approximation for it, but that's not what we want right now. Right now we want this. So let's do another one. Suppose I said, all right, here is my right triangle. Now this is 30, this is 60, and this is 90. If I give you the short leg, again, let's say that this is 4. Well, the hypotenuse is going to be double that, that's 8, and the long leg is going to be 4 times the square root of 3. Done. Now, I guess you could complicate matters very slightly by doing this, 30, 60, 60, 90. If I tell you the hypotenuse is 10, well, that means the short leg is 5, and that means the long leg will be 5 square roots of 3, but that's not very complicated. I suppose the worst case is if I give you, let's try this one. This one's going to come up later, so let me forget that. Let's try, okay, so here's 60. If I tell you that this is 1, establish what it is that I gave you. This is the hypotenuse. So I know that the hypotenuse is double the short leg, and if this is the 30-degree angle, then the short leg is across from it, so it would have to be 1/2. Excuse me. Now the long leg is easy to do. It's 1/2 times the square root of 3. A lot of times when you see this written, what you'll see is it's the square root of 3 over 2. So there you have it. Whatever I give you, you should be able to figure this out. I was going to do another example. Let me make a new page. Let's do one that's a little bit more complicated. Suppose I tell you, here's your right triangle. And let's say here's the 60-degree angle. Now the worst thing I can do, I guess, is give you the long leg. So let's do an easy one. Suppose I tell you that this is 5 times the square root of 3. Well, that's easy. That makes the short leg 5, which makes the hypotenuse 10. Now, if you watch the video on the 45, 45, 90 triangle, let's do this. Let's make a 60, 30. Suppose I told you that this was 8. Well, if I know the short side, to get the long leg, I would have to multiply by the square root of 3. So wouldn't it make sense then that if I know the long leg, shouldn't I have to divide by the square root of 3 to get the short leg, right? Now I can't leave it like that, so I'll fix that up. And that leaves me with 8 times the square root of 3 over 3 for the short leg. And then for the hypotenuse, I simply have to double the short leg. So that's going to give me 16 square roots of 3 over 3. But I think this problem is the worst case scenario. But let's just try to sum this up based on the short leg. If I give you a 30, 60, 90 degree right triangle, if I tell you, let's call this short leg, and the hypotenuse is 2 times the short, 2 times the short leg, and the long leg is the square root of 3 times the short leg. And from that relationship, you can solve any 30, 60, 90 degree right triangle.